Hello again, everyone. Mr. Reeves back with you, and today we're going to be looking at some properties of rotations, specifically looking at what a rotation is and how it affects the image that we start with. So if you look in your textbook, they define for us a rotation is a transformation that turns a figure around a given point called the center of rotation, and the image has the same size and the same shape as the pre-image, although its orientation or the direction it turns changes. Just to let you know, we're going to be sticking with rotating around the origin as our center of rotation, and while we will be looking a little bit at all kinds of angles of rotation, you're going to only be specifically asked to work with rotations and increments of 90 degrees. All right, so let's just go ahead and take a look here. I've pulled up my handy dandy Inspire, and I've got a triangle right here. This orange triangle outlined in blue is in the first quadrant. I've got three vertices of the green, the red, and the blue, and you could see I've got these circles here that show how those points are going to travel as we rotate around the origin. So I'm going to go ahead and click on the spinner here, and you can see that I am moving the triangle in a clockwise direction. Up in the top left-hand corner over there, you can see it's giving us the angle of rotation. Now follow those vertices, all right? So the color is important. You could see that the red vertex is staying on the red circle, the green vertex is staying on the green circle, and the blue vertex is staying on the blue circle. All right, so now I'm going counterclockwise. And the fact that those points are staying on the circle is an indicator that the distance is always the same. So when you rotate an object around a center, and again for us that center of rotation is going to be the origin, the distance of each point away from that center of rotation is preserved. It is only the location that changes, and it changes based upon the angle that we have. So for example, right now I have a rotation of 90 degrees in a clockwise direction. So what that means is if I were to take out a protractor and I were to measure that angle, then I would find out that I have a 90-degree angle between where my point originally was and where it is now. So I'm going to go ahead and try to grab it. There we go. Alrighty. Okay, and can you see right here is where my point originally was, and it makes a 90-degree angle and it moves there. And if I follow that, I can do that as well with that blue point. Blue to blue makes 90, right? And if I do it one more time, we should be able to see that red to red also makes 90. All right, so can we make this go away? There we go. So that again is 90 degrees in a clockwise direction, and we can keep going. By the way, the angle of rotation up there is always giving us the clockwise rotation. If I go counterclockwise, for example, right here, it says 270. That would be 270 degrees this way or 90 degrees that way. Let me pull up that protractor again real quick here, and you can see that for each of these, like 70 goes with 110 and 100 goes with 80. Those two will always add up to 180 on a protractor. When we rotate, because the circle is 360, they will always add up to 360. So a 270 degrees clockwise, which is what we have there, 270 degrees clockwise would be the same as 90 degrees counterclockwise. Does that make sense? So let me just show you real quick. All right, so if I started here and traveled there, so going this direction here, let me do it on the green circle because it's smaller. So going this direction, wow, that is really bad, Mr. Reeves. Let me try making this line a little wider and see if I could do a little better. So I'm traveling along this circle. Still not great, right? Okay. So going that way, that is 270 degrees, right? But if I went this way instead, that would be 90 degrees. And you notice I land at the same location right there. And if you add 90 plus 270, you get 360, okay? So whether I go clockwise or counterclockwise, I can arrive at the same location. And those two numbers will always add up to 360. This is going to be important to know later on as we're doing some problems here, okay? So clockwise and counterclockwise. All right, so here on my second example, you could just see that I've simply limited us to the 90-degree increments that we're going to be looking at, right? So this right here is 90 degrees clockwise, which would be 270 counterclockwise. This one is 180. The great thing about 180 is 180 clockwise is the same as 180 counterclockwise. If I go one more time, I've gone 270 in this way. This is the one I was just showing you. Or if I went that way, it would be 90. And if I go one more time, I'm 360 degrees, which gets me back to where I started. Or I could also make that 0, right? Because, of course, if you go 0 degrees, you're back where you started. All right, so that was just a quick introduction to rotations around the center. I hope this helped you get an idea of what we're going to be doing as we look more carefully at rotating polygons around the center. Thanks for watching, everybody.